right, making it full screen. So for our warm-up today, so every single group here figured out that because the second derivative was negative, you have a function that's concave down. So that's great. That doesn't tell you whether you have a max or a min, but there's one more piece of information that they give you, which is that the first derivative is 0. If the first derivative is 0, what does that mean? Yes, very good. Okay, Ishan was jumping to the final conclusion, which is true. But Jennifer, I like that you were drawing the more immediate conclusion, which is if the first derivative is 0, that means you have a horizontal tangent, right? You've got a tangent line with a slope of 0. So if you have a horizontal tangent on a concave down function, there's only one place it can go, and that's at the top, right? It's the only place your tangent line can be horizontal. So whenever you have and you have to write this down, but when you have a horizontal tangent on a concave down function, what does that mean? That means that you have a rel max. And what's the point? The point would be at the point 318. All right, now some of you wrote because statements, which are incorrect. That's okay, because you haven't learned them yet. So that's what we're going to do today. All right, so today we are doing section 4.3b. This is 4.3b. Same learning target as yesterday, except if you like to, I don't know how many of you like to give your notes a title, but if you want to give your note a title today for 4.3b, it would be second derivative test. Second derivative test. Now, sometime in the next few minutes, we're going to have a visitor. When our visitor comes, I'm just going to pause. We'll listen to the visitor for a few minutes, and then we'll go back to the lesson. All right. So, who do you think the visitor is?
Rollin? Mr. Rollin.
It's Mr. Rollin. Yeah. Okay. All right. He wants to talk to you about the AP exam. Okay, so second derivative test for relative extrema. This is your last test that you have to learn in this unit. So you learned yesterday, you learned the first derivative test for relative extrema, and you learned the concavity test. Today, you're learning the second derivative test for relative extrema. Now, the second derivative test is not a test for finding points of inflection. That's what the concavity test is for. The second derivative test is an alternate way of finding relative extrema using the second derivative. That's why it's called the second derivative test. All right, so how do we do it? Well, we find our first and second derivatives. We find the values where the first derivative is 0, which means you have a horizontal tangent. You plug those into the second derivative, and if you get a negative, you've got a relative max. If the answer is positive, you have a relative min. There are problems with the second derivative test. Oh, here it comes. All right, let me pause this. Top, it's that Touch ID. Oh my gosh, life is so much easier with Touch ID. All right. So anyway, the only other thing I want to point out about this is that so notice your first derivative is 0, second derivative positive, you have a min, negative, you have a max. If your first derivative is undefined, you can't even use this test. If your second derivative is 0 or undefined, the test is inconclusive. You might have a max or a min there. you don't know. So because of that, I only use the second derivative test when I absolutely have to. I do all of my relative maxes and mins with the first derivative test, just making a sign line. So the only time I ever use the second derivative test is if I can't make a sign line. So, and there's two different types of problems they can give you where you can't make a sign line, and we are going to see both of those in the next few minutes. All right, but we gotta get a move on because it's a short day. All right, so use the second derivative test to find out relative extrema for this function. First thing I want you to do is find the first derivative, and then find where the first derivative equals 0. You're gonna have some fun with factoring on this one. So I'll give you maybe a minute, 90 seconds, to find the first derivative and find the zeros.
Does it factor or do it?
It factors.
Okay.
I always liked factoring.
All right. So to me, I look at this and I see a 3 and a 3, and I see an 8, and I think, oh, it's 9 and 1, right? So, yeah, get in that factoring mode. If you're not there, do factoring as much as you can because there's a lot of factoring on the exam. All right. So we found our zeros where the first derivative is 0. What do we do with these now? We have to plug them into the second derivative. So everyone find the second derivative. Yes. Yes. 3 times 2 is 6. So when we find the second derivative, you just plug each of these points in. So f double prime of negative a third, well, that's 6 times negative a, 1/3 minus 8. Okay. So you end up with negative 2 minus 8 or negative 10. Numerically, the number doesn't matter. It's the sign that matters. Is this positive or negative? This is negative, right? If we plug in a 3, we get 18 minus 8. Is this going to be positive or negative?
Positive.
Positive. All right. So we're going to do each one separately. We're ready to write our answers. That's all there is to it, right? You find the zeros of the first derivative, plug them into the second derivative. Positive is a min, negative is a max. All right, so we write our answers. So a rel max occurs at negative 1/3, comma, something, because. All right, so your because statement is pretty much just writing out how you figured this out. So how did we know that we had a relative max at negative 1/3? Because f prime of negative 1/3 equaled what?
0.
0. And f double prime of negative 1/3 was negative. It's just pretty much like, how did you know? I knew because the first derivative was 0 and the second derivative was negative. Now I got to find a y value, right? So if I find the y value at negative 1/3, so I get negative 1/27 minus 4/9 plus 1. Is that right? Okay. So negative 1/27 minus 12/27 plus 27 27ths. So I get 14 27ths. Did I do my math right?
Yeah.
Okay. 14. That is not what I got first period, which means I did my math wrong first period and nobody got me. Anyway, I'm pretty sure I put a negative here first period. Anyway. All right, other one. A rel what? Min occurs at 3 comma something because f prime of 3 equals 0 and f double prime of 3 is greater than 0. All right, to find the y value, where do I plug in to get the y value? Original function. So I plug in a 3, I get 27 minus 36 minus 9.
Oh, wait, no.
Did I do something wrong?
No, that's right.
Oh, okay. So 27 minus 45, so negative 18. And that's it. That's the basics of second derivative test. Now we have other problems to do, but are there any questions on this? Because if you get this, you pretty much get it. No, there's more. Yeah, sorry.
What happens if you're unable to find the second derivative? Like if your first derivative is 3 or something, how would you find the second?
So if your first derivative is 3, that means that your function is a line, which means it shouldn't have a relative maximum. Yeah, that's okay. All right. By the way, just quick little side notes, just to get this on the recording. The actual number for the second derivative, like here, this number says that our second derivative at 3 is 10, right? What does that number mean? Basically, it tells you the degree of curviness of the function at that point. So if your second derivative is 0, it means there is no curviness. Your function's flat. It's a line. So when you have a second derivative of 0, you're flat. As the second derivative number gets bigger and bigger, you're getting curvier and curvier and curvier at the point, right? But there's no like slick trick to know. Like slope, I know. Like if someone says, hey, this line has a slope of 5, I know basically what the line's going to look like, right? But if someone says, hey, this function has a concavity of 10 at this point, all I know is it's going to be concave up and it's going to be kind of curvy. But I can't like draw an accurate concavity of 10, right? So the number for the concavity means something, but not a lot. It doesn't tell you a lot. So it's more the sign that's important. All right, this is an actual AP problem. It's been paraphrased, but it is an actual problem from an old AP exam. The College Board has not published any multiple choice problems from AP exams since 2003. So the College Board has, bless you, been hoarding their multiple choice problems for the last 16 years. And they probably will never publish any more again. So they like to reuse those problems. So instead, they keep sending teachers little like packets of practice problems and say, well, we're not going to issue any exams, but here's some practice problems to use with your students, right? So they keep doing that as kind of a consolation since they keep not publishing the exams anymore. So since 2003, they haven't published multiple choice. They used to do it like about every 5 years. So, but now they just stopped. So anyway, but this is an actual problem. I just when I typed it up, I paraphrased and abbreviated. But so suppose f of 5 equals negative 2, f prime of 5 is 0, and f double prime of 5 is 26. What can you conclude? Take 30 seconds in your groups to make a decision of what the answer is. Mm-hmm. That's exactly right. Like I planned it that way.
That makes so much sense.
All the questions are
Wouldn't it? Oh, okay. Well, we'll draw it. Okay, so drawing you guys back in. All right, group in the back corner. What do you think the answer is? B? Anyone get anything different? Are you sure? Tell me why. It is the same thing as the warm-up problem. Okay, yeah. So, it's easy to get second derivative tests mixed up because it kind of goes opposite of what you think. When the second derivative is positive, you have a min. Negative, you have a max, right? If you ever get confused, just draw yourself a quick concave up function and think, where does the horizontal tangent have to go? In this case, it's at the bottom, right? So this would be a min. All right, any questions on that? Nice piece of cake. Wouldn't it be nice if all your test questions were like that one? Okay, give this one a try. So find the relative extreme. I want you to start by trying it with the second derivative test. I'm going to pause recording. So we find y prime, 12x cubed. We set this equal to 0, and we get x equals what? 0. So that was easy enough. We find y double prime. We get 36x squared. We plug in the 0, and we get 0. Inconclusive. So does that mean we just stop?
No.
No. When second derivative test fails, you have to go back and do the first derivative test, which is why I always do the first derivative test first anyway. So first derivative test says we make a what? Sine line. So for what? Y prime, y double prime? Y prime. So if I pick a negative number and plug it into y prime, do I get a positive or a negative? Negative. What about if I pick a positive? I get a positive. So my function is decreasing, increasing, which means we have a rel min, right? A rel min occurs at 0, -8 because, what's our because statement for first derivative test for rel min? Very good, because y prime changes from negative to positive at 0. There used to be a set in the 80s. There was this great set of videos, calculus videos, that were made by a group. The name of the group was called the Standard Deviants. And if you took statistics, you'd find that funny. And so anyway, and when they got to second derivative test, this girl, they had this example. I don't know if it's the same one, but they would start working it out, and then she would stand there and she'd say, when you plug in the 0 into the second derivative, you don't get a positive or negative, you get jack squat. And then on the screen, the whole screen would flash, jack squat, jack squat, jack squat. And it was so funny. I always loved that video. But they're so old now, and they're only on VHS, so I don't know. Someday maybe I'll find them again. Yes?
So what does it mean, like, on the graph if y double prime?
So what ends up happening on a fourth degree is, because it's a fourth degree, your graph, like a second degree, we all know is a parabola, right? Well, a fourth degree looks kind of like a parabola, except it's got kind of a fat, flat bottom. So I think it's kind of like a Queen song, if you know the Queen song, Fat Bottom Girl. So it's got like a flat, fat bottom. And so when you have a fourth degree, the sides go up faster. The sides are steeper. But when you're in between -1 and 1, you actually flatten out much, much more quick. Like, you get flatter for a bigger part of your time. even though it never actually is 0 the whole way through, but it's so close to 0 that your limits end up approaching 0 for both the first and the second and the third. Like they just keep, it's just always 0. So how do you find that? The only way to do it is to make a sign line, because you're doing it based on concavity. The concavity is basically just approaching 0 there because it's so flat. Whereas here, you get a nice curviness to it, so you get this nice positive concavity. So even though it's technically not flat, your concavity essentially is approaching 0 there because it kind of flattens out. Once you get past quadratics, you end up with a flatter middle. Like even cubics, even though they don't go flat, they go flatter, right? And the higher you go in degree, when you're centered around 0, the flatter you get in that little spot. So you end up with this 0 concavity for all those higher degree functions. Anyway, all right. We probably don't have time, but we're going to try to do as much as we can of 2004 before the bell rings for core. So, oops, that's not how I get to it. How do I, oh, here. That's what I want. All right. Yes, but I'm going to talk to you about it first. So 2004, the problem that we're doing, this is a no calculator question. It's number 4. Ignore this graph at the bottom. That has nothing to do with it. So you have this beautiful function that is this explicitly or implicitly defined? Implicitly defined, right? Okay, so you have this beautiful implicit function, and they want you to show in the part A what the derivative is. So they give you the answer. The reason they give you the answer is, one, just to be nice, so you have a goal that you're working towards, you know, if you get it right or wrong. But really, it's because you're going to have to use this in the next 2 parts. And if you don't get it right, you're sunk, right? So they give you the answer so that if you don't get this first part right, you can still get parts B and C correct, right? If they give it to you, always use what they give you, right? If you don't match, please don't use your answer, right? Use theirs. So, because theirs is probably right. So anyway, so you do part, probably. So you do part A, little implicit differentiation. Part B, you have to show where the tangent line, that the tangent line is horizontal at x equals 3 and find the y value at that point. And then part C, find the second derivative. Does the curve have a local max, min, or neither at the point? When you have a first derivative defined in terms of multiple variables, there is no way you're making a sign line for that thing, because you have multiple variables as input. It's not just an x value. It's just not just a number line. It's the whole, graphing system, coordinate plane that you're plugging in for your input. So you can't make a sign line. So you have to do this with second derivative test. All right. So I'm going to give you a few minutes on your whiteboard to see what you can do with this. All 3 parts. So it looks like everyone got the correct first derivative. Were there any questions? Did you all remember your implicit with a product rule? Looking for smiles. Yes? 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 Okay, good. Because it looks like it on the board, but sometimes you never know, right? All right. So we all remembered our implicit with our product rule. I'll show you the scoring guidelines in just a minute, just so you know that Part A was worth 2 points. How many points is the whole thing always worth?
9.
9. Part A was worth 2 points. First point was your first line, basically. Did you differentiate implicitly? And then the second point was just for simplifying. So really it was, did you do the algebra properly to simplify to the correct answer? Most people, if you differentiated implicitly, you're going to do the algebra right because you know what the answer is. So you kind of work towards it. So anyway, so that was Part A. Part B was worth 3 points. And I'm guessing that most of you got 2 out of the 3. So we want to know if there is a point with an x-coordinate of 3 where the tangent line is horizontal. Horizontal tangent means that the derivative is equal to what? 0. When we want to know if the derivative is 0, do we set the top equal to 0, the bottom equal to 0, or both?
Just the top, right? Because if the bottom's equal to 0, what's your slope? Undefined, right? That would be more like a vertical tangent instead of a horizontal tangent. So, all right, so you set your top equal to 0. Just about everyone found the point was 3, 2, which was good. So you got a point just for setting the derivative equal to 0. If you wrote equals 0 next to the derivative, you got a point, or the top is fine. They showed both. So, so you got a point for that. By the way, if you, okay, you got it, yeah. So I think everyone here, ooh, wait. Okay. No, you got it too. Oh, yeah, you got it. So if you wrote this and never wrote equals 0 somewhere, you didn't get that point, even if you got the right answer, right? So be careful, make sure whenever you're solving an equation that you write the equation that you're solving, even if it's just setting something equal to 0. All right. The top is fine. Okay, it's equivalent. All right. However, there was a third point that just about everyone missed. And the College Board realized it, and a few years later, they rewrote a similar problem and made it more of a trap. So here, the 3-2 was correct. It was the only answer you got. But do you know for sure? Do you know for sure that the point 3-2 is actually on the original function? So the third point was to check by plugging your point into the original function to make sure it was really there. So a few years later, they gave a similar problem, similar exercise. You found a point, but when you plugged it into the original function, it wasn't actually on the function and there wasn't an answer. So they like to mess with you a little bit. So you had to verify that the point was on the function. Almost nobody got that point. So anyway, all right. Then yeah. It actually, I think in the problem that I'm thinking of, you got 2 answers, and one of them was. All right. Okay. Okay. Part C. Find the second derivative. You had a beautiful implicit differentiation with quotient rule problem, right? So you find your second derivative, which most of you guys,
Yeah, we messed that up.
Yeah,
It was
okay.
minus and then over the square.
okay.
But we
Oops.
used that one to find it.
Okay. All right. So you have an implicit. Did you guys do a minus and just canceled it and put a plus? Okay, that's fine. So you find your second derivative. I personally, when I have a number to plug in, I never simplify. I just plug the number in, right? It's always easier to simplify with numbers than letters. So as soon as I would get my second derivative, I would plug the 0.32 in here and just find what the number is. I'm not seeing a lot of correct answers. I'm going to show you the answer so that you can see what the actual value was. Scoring guidelines. The second derivative was worth 2 points. So you got 2 points for your second derivative. So this looks great, right? So you guys would have gotten 2 points for your second derivative. Well done, right? Okay. And you guys got your answer. So the answer when you plug in the point was -2/7, which, you guys got. It's just not reduced. You guys did well on this.
We plugged in math for X on accident and then realized it.
Oops. Okay. Yeah. You guys didn't get to it. You guys, there's some sort of a math mistake in there somewhere. So that's okay. All right. So, so that was just a point, but then your final answer, since y prime is 0 and y double prime is negative at your point, at the point 3,2, the curve has a local max. So you never have to say the word by the second derivative test. It's not a theorem. It's just a procedure, right? So your because statement is because the first derivative is 0 and the second derivative is negative. Watch out, because I kind of dinged one group and made them change it, but I see another group also who called the function f. The function is never ever defined as f. As a matter of fact, this isn't even a function.
So you got to be careful. Don't give it a name that it doesn't have. The only way that you can call this thing is y, right? Because this thing right here, absolutely not a function. So because of this, you can't give it a function. So, all right, and that ends lesson. So